In Chapter 4, we're going to start looking at properties of triangles. So first of all, let's just explain that a triangle is the smallest number of sides you can have for a shape. So if you imagine having just one side, that's obviously not a polygon. Two sides just makes an angle. You need a third side in order to make it a polygon. And then we can label the vertices, say as A, B, and C. So how we would name this triangle, if we want to name it, we would draw a triangle and then write the letters A, B, and C. Now there's two ways that we can classify a triangle. One way is by what the sides look like, and one way is by what the angles look like. So if we have all three sides different, so remember these marks mean that you have sides congruent. So like if we have two sides with just one mark, that means that those two are congruent to each other. If we had three sides with one mark, that means all three of those are congruent to each other. But if we have a side with one mark and a side with two marks, that means that those are different lengths, and same with a side with three marks, different lengths. So this means that all three lengths are different. So there are zero congruent sides, no congruent sides. We call that a scalene triangle. If you have at least two sides congruent, we call that isosceles. And if you have all three sides congruent, you guys actually already know this word, it's equilateral. And that's if you have all three sides congruent. Alright, then we can look at angles. So if all three angles in a triangle, they're all acute, and that means they're all less than 90 degrees, we call that an acute triangle. If we have one right angle in the triangle, we call it a right triangle. And if there's an obtuse angle in the triangle, we call it an obtuse triangle. Now, if you have an obtuse triangle, the other two angles are going to have to be acute. So if you think about just, again, drawing triangles, if you were to try to make a triangle with, say, one obtuse angle like that and then another obtuse angle, well, then they wouldn't meet together to make a triangle. So you can only ever have one obtuse angle in a triangle. Then we could have all three angles congruent. And again, you already know the term for this, it's equiangular. Alright, let's look at example 1. Now in this example, I'm going to assume that you already know how to use a protractor. If you don't, please go watch the video on how to use a protractor. The three of these angles here should all measure to be 60 degrees. And so what that tells us then is it is an equiangular triangle because all three angles are the same. And then also if we look at the sides, you can see they're all marked congruent, and that makes it an equilateral triangle as well. Well, if we have both equilateral and equiangular shapes at the same time, that means it's a regular shape. Alright, triangle TRS. This one, the top angle is about 88 degrees. Bottom left is about 54 degrees, and the bottom right is about 38 degrees. Now, when you're measuring these, if you don't get that exact number, that's okay. As long as you're within a couple degrees of that, that's fine. So this triangle, all three sides are different lengths, so that means it's a scalene triangle. And as far as the angles go, well, they're all less than 90 degrees, so that is an acute triangle. Oh, and I guess I should have said for the first one that this one is acute as well, because they're all less than 90. For the third triangle, we've got two of the sides marked congruent. That means it's going to be an isosceles triangle. And it's going to be acute. So all three angles are less than 90. This one is about 34, this one's about 78, and this one is also about 78 degrees. Alright, example 2. Determine if the triangle in the graph is a right triangle. Well, you can see pretty clearly that it's going to be a right triangle because this is horizontal and this is vertical. But let's show in a bit more rigorous of a way that that is the case. So if we look at segment PQ, If we look at the slope of that, so remember slope is rise over run, it's how much you go up or down divided by how much you go left or right. So for this one, to get from P to Q, we go up 0 units. So the slope of that is 0, then divided by, and then we go 1, 2, 3, 4 to the right. 0 divided by 4 is 0. So that means that the slope is 0. For QR, for that one, the rise is we go down 1, 2, 3. So for QR, that's down 3. And then we go to get from Q to R, we go left and right, or left or right 0. We don't move to the left or right at all. So that's an undefined slope. If we're dividing by 0, that's undefined. So QR has an undefined slope. And we know that a slope of 0 and an undefined slope, that's a horizontal slope and a vertical slope, are perpendicular. So therefore, that must be the case that this is a right triangle because PQ and QR are perpendicular to each other. On a shape, we have interior angles. Those are the angles inside the shape, like these 3 angles here. So those are called interior angles, interior meaning on the inside of the shape. But then if we extend the lines of the shape, just like in both of these pictures, we also get exterior angles. So those are these angles on the outside of the shape formed by the extension of the sides. So those would all be exterior angles. So when you extend the sides of the polygon, other angles are formed. The original angles, the ones again inside, those are called interior angles. And the ones that form, the kind of technical way of saying it is that they form linear pairs with the interior angles. So if you think about this line right here, well, this angle right here is a linear pair with this interior angle. And so that's how you can tell if it's an exterior angle or not, is it adjacent to the interior angle. And in fact, both this angle here and this angle here fit that description. So there are 6 exterior angles then. Theorem 4.1 tells us that the sum of the measures of all the angles of a triangle, they all add up to 180 degrees. So that means if we were to take this angle, add to it this angle, and then add to it this angle, if we added all 3 of those angles together, we would get 180. So the sum of the measures of the triangle is 180 degrees. In example 2, we're going to use this fact. So if we look at a triangle, and we say angle A, we'll say that's x degrees. Angle B, we'll say is 2x degrees. And angle C is 3x degrees. Well, then we can say that all 3 of those angles added together should equal 180. So if we take angle A, which is x, plus angle B, which is 2x, plus angle C, which is 3x, add all of those together and we should get 180. Combine like terms over here may help to think of that as a 1x. So combining like terms gives you 6x on the left side. And then we can divide by 6. And that gives 30 for x. Now we're not quite done yet. So what we need to do now is figure out the angle measures. So angle A, that's fairly simple to find. X is 30, so that means this is a 30-degree angle. And then B is 2x, so that's 2 times 30, so this is a 60-degree angle. And then angle 3 is 3x. 30 times 3 is 90, so that's a 90-degree angle. So one of the angles in the triangle is a 90-degree angle. That's a right angle. So that means this is a right triangle. Now let's look at theorem 4.2. So what this one tells us is that these 2 angles here, the sum of those angles, if you add them together, you will get this angle right here. So let's talk about why that is. So let's think about their relation to this angle right here. This is the important angle. So that's angle ACB. So if we look at, ignore this part, just look at this. We have this angle right here, and then angle 1. And so these two angles together have to be 180 degrees. So they make up a straight line here, so this angle plus this whole thing must equal 180 degrees. So let's actually use an example here. Say this is a 30-degree angle, that would mean this would have to be 150 degrees. Alright, so then if we ignore this part and look here, well, I know that all three of these angles must add up to 180 degrees. And so that means 30 plus whatever B is plus whatever A is, all those must add up to 180. And so if this one's 30, well, that leaves only 150 for these two together. Now, it doesn't matter what exactly A and B are, as long as they add up to 150. They're going to have to add up to 150 if this one is 30, because all three together have to add up to 180. So that means that these two must be the same as this one. So if you put these two angles together, if you add them together, you will get this angle measure here. So the measure of angle 1, which in this instance is 150, must equal these two added together. That's the measure of angle A plus the measure of angle B. Now let's use this fact in example 3. So I know that these two angles added together must be the same as this angle here. So if I take x plus 70, I can set that equal to 2x minus 5. And then I can solve for x. So we've got variables on both sides and numbers on both sides. So let's try to get everything with a variable maybe over to the right side. We could do that by subtracting x from both sides. And then get everything without a variable over to the left side. I can do that by adding 5 to both sides. And I get that x is equal to 75. Then to find the measure of angle JKM. Well, JKM is this one right here. I'm sorry, JKM is this one right here, the 2x minus 5 angle. So then what I can do is I can take that x value and plug it in for x in 2x minus 5. So 2 times 75 minus 5, that's going to be 150 minus 5, which is 145. So the measure of angle JKM is equal to 145. If you remember back to talking about theorems and postulates, so theorems were things that we prove based off of postulates. Postulates, again, are things that we accept to be true so that we can do geometry. Just kind of statements or facts that are obviously true or that we accept to be true. And then we can use those postulates to prove things. And when we prove them, we call that a theorem. Sometimes when we prove a theorem, we get some extra little things along with it. And when we have that happen, we call those corollaries. So here we have a corollary to a theorem. So that means this corollary is an extra bit that we get along with this theorem that we proved was true. So it's a statement that can be proved easily using the theorem. So we have a corollary to this triangle sum theorem. Again, the triangle sum theorem was that all three angles in a triangle add up to 180 degrees. And so the corollary to that, or a corollary to that, is that if you have a right triangle, then that means that these two angles that are not a right angle, must be complementary. They must add up to 90 degrees. And that makes sense if you think about it. So we've got 180 degrees for all three of them. Well, if this one's 90, then that leaves just 90 for these two. So that means that again, acute angles of a right triangle must be complementary. They must add up to 90 degrees. Example 4, we're going to use this fact. So again, what I could say that all three of these angles add up to 180. So I could say 90 plus x minus 6 plus 2x equals 180. Or I could say, well, this one's 90, so that leaves just 90 for these two, meaning that 2x plus x minus 6 must equal 90. Combine like terms here, 2x and 1x makes 3x. And then add 6 to both sides. We get that 3x is equal to 96, and then divide by 3. So then x is equal to 32. Now I, again, was asked to find the measures of the angles. I wasn't asked to find x, so we're going to need to use x then to get the measures of the angles. Well, this one, we just take x and multiply it by 2, so that one is going to be a 64-degree angle. And then for this one, we subtract 6 from 32, so that's going to be 26.